Hello students, I am Dr. Hina, working as an assistant professor in Department of Applied Sciences, CEC, CGC, Landra. So today we are going to discuss the topic consistent and inconsistent system of the linear equations. So before watching this video, I would recommend the students to please go through the topics such as matrices, properties of the matrices, row echelon form and the rank of the matrix. So as the name suggests, firstly we will discuss what are linear equations, then system of linear equations, then homogeneous and non-homogeneous system of the linear equations, what do you mean by consistent and inconsistent system, how to find the solution of the homogeneous and non-homogeneous system of the linear equations, and in the last we will see some applications and the conclusion. So first is linear equation. So as the term suggests linear, that means the degree of the unknown variable should be 1. For example, if I write 2x plus 3y is equals to 2. So here unknown variables are x and y and the degree of x and y are 1. So it is linear equation. If I write this x plus y plus z is equals to 2, here there are 3 variables and the degree of each variable is 1. Again this is a linear equation. Suppose if I write x square plus y square plus z is equals to 2, here the degree of x and y are 2. So this is not a linear equation. I hope this definition is clear to everyone. In general, any linear equation can be written as a1x1, a2x2, a3x3, a(n)xn is equals to b, where x1, x2 up to xn are the unknowns and a1, a2, an up to b are the constants. And if we have more than one linear equation, then we say that it is a system of linear equations. For example, if I write 2x plus 3y is equals to 2 and x plus y is equals to x plus y z is equals to 2, this is called a system of linear equations, and in coming slides we will see how to find the solution for this system of linear equations. In general, any system of linear equations can be written in this form, where a11, a12, a1n and so on, these all are the constants and x1, x2, xn are the variables. Any system of the linear equations can be written in the matrix form as ax is equals to b. How? Let's see here. Suppose I have these 3 equations, 2x plus y plus z is equals to 2, x plus y minus z is equals to 5, and the last one 3x plus y plus z is equals to 7. So this is more than one linear equation. Here there are 3 linear equations. So this is a system of linear equation, and now we see, I will write it in the form of matrix. How? 2, 1, 1, then 1, the coefficient of y here is 1 and here it is minus 1. 1, 1, minus 1, 3, 1 and 1. This x, y, z and these values 2, 5 and 7. So 2, 5 and 7. When you multiply these two matrices, you will get these equations. See, 2x plus y plus z is equals to 2 and x plus y minus z is equals to 5, and last 3x plus y plus z is equals to 7. So any system of the linear equations can be written in this form, where this matrix is called as A, this is x and this is b. So I have written here already that any system of the linear equations can be written in the form of ax is equals to b, where A is called as, this matrix A is called as coefficient matrix, x is called as unknown vector, and this B column vector consists of these entries B1, B2 and B3, that is 2, 5 and 7. So any system of linear equation can be written in the matrix form as Ax is equals to B, where A is called as coefficient matrix and X is called as unknown vector. Next, homogeneous system and non-homogeneous system. in homogeneous system, all BIs must be 0. These are the BIs B1, B2 and Bm. If they all are 0, then we say that it is a homogeneous system. And if at least one of them is non-zero, then we say that it is a non-homogeneous system. For example here, this system is called as non-homogeneous system. Why? Because here see B1 is 2, B2 is 5 and B3 is 7 and they are non-zero, therefore this is non-homogeneous system. If I write like this, 2x plus 3y is equals to 0, x plus y minus z is equals to 0 and last x plus y plus 2z is equals to 0. So all BIs are 0 here. So this is homogeneous system and this is non-homogeneous system. I hope this is clear to everyone. And in the matrix form, Ax is equals to B. If this column vector B is 0, then we say that it is a homogeneous system. And if B is non-zero, for example here B is 2, 5, 7 column vector and it is non-zero, so we say that it is a non-homogeneous system of equation. So if capital B, that is column vector, is 0, then we say that it is a homogeneous system. And if it is non-zero, then we say that it is a non-homogeneous system. Now further we will see consistent and inconsistent system of equations. So consistent means if the system of linear equation has at least one solution, then we say that it is a consistent, and if it has no solution, that means then we say that it is an inconsistent system. For example, let's see this with an example. What do you mean by consistent and inconsistent? See, if I write x minus y is equals to 2 and x plus y is equals to, let's suppose, 4. If I add them both equations, we will get 2x is equals to 6 and x is equals to 3. Similarly, if I put x is equals to 3, 3 minus y is equals to 2, you will get y is equals to 1. So this x is equals to 3 and y is equals to 1 is the unique solution of this system of linear equations. So we will say that this system of linear equation is consistent because it is having unique solution. If I write x plus y is equals to 2 and 2x plus 2y is equals to 6, suppose, you will see when you subtract them, or if I take, let's suppose, 2x plus x plus y is equals to 2. You will see this system of linear equation will have no solution. If you subtract them, if I multiply this by 2, you will see this will have no solution. In this case, you will get left hand side 0 and here you will get minus 2. So this cannot be possible. So this system of linear equation will have no solution. So we will say that this system of linear equation is inconsistent. Means these system of equation is having no solution. Next we will further see how to solve the non-homogeneous system of linear equations and homogeneous system of linear equations. So firstly we will see how to solve the non-homogeneous system of linear equations. So any non-homogeneous system of the linear equation will be in the form of Ax plus b, where b is non-zero. So this system of equation is consistent when rank of A is equals to rank of augmented matrix. So this is when rank of A is equals to rank of this. This is called as augmented matrix. We will see further this with an example. What do you mean by augmented matrix? Next slide is the example which is showing how to solve this non-homogeneous system of equation. And this is inconsistent. When rank is not equal, then this system of equation is inconsistent. Further, if the rank of A and rank of augmented matrix is equals to the number of unknowns, then it will be having unique solution. And if rank of A is equals to the rank of augmented matrix and is less than the number of unknowns, then we say that it has infinitely many solutions. So we will see this with an example. It will be more clear to you. So this is an example. See how to solve this now. So we have given x minus 5 plus 2z is equals to 2, 2x plus y plus 4z is equals to 7, 4x minus 5 plus z is equals to 4. So clearly this is a non-homogeneous system of equations. We can write it in the form of Ax is equals to b, where A will be the coefficient matrix 1, minus 1, 2, 1, minus 1, 2, 2, 1, 4, 4, minus 1, 1, 4, minus 1, 1. So this will be now A, and B will be 2, 7 and 4. So now how to solve the system of equations? In the previous slide we have seen that if the rank of A and rank of augmented matrix. Now this is A, augmented matrix will be the matrix A as it is 1, minus 1, 2, 2, 1, 4, 4, minus 1, 1, and we have to add the column B also here, like 2, 7 and 4. So this is called as augmented matrix. If you add the B column, the B matrix in the A, you will get the augmented matrix. Now we have to check whether the rank of A and rank of augmented matrix is equal or not. If it is equal, then we will say that the solution system of the equation is consistent. And if it is not equal, then we say that the system of linear equation will have no solution. Now we have to check the rank of both the matrices. How will you check the rank of the matrix? By converting them into the row-echelon form. So we will convert them into row-echelon form. I have written this here already. When you reduce the system of the linear equations, you will get this. I will explain this how it will come. Now you have 2, minus 1, 2, 2, 1, 4, 4, minus 1, 1, and 2, 7, 4. Now you have to reduce this matrix into the row-echelon form. How will you reduce it? Sorry, here it is 1. I will apply the operation R2 minus twice of R1 and R3 minus 4 times R1. Because I have to convert them into 0, these two entries. So I will make sure to apply these row operations, and by applying these operations you will get one, minus 1, 2, 0, 3, minus 7, 0, 0, 7, and 2, minus 4, 7. You can apply this and you will see, you will get this form. Now you can see that this is matrix A and this whole is the matrix augmented matrix B. Clearly you can see that the rank of A means the number of non-zero rows in the row-echelon form, that is 3. That means rank of A is 3. Similarly, you can see the rank of augmented matrix. Again, the number of non-zero rows in the row-echelon form of augmented matrix is again 3. So here the rank of A is equals to the rank of augmented matrix. So the system of equation is consistent. In case if its rank is 2 and this rank is 3, for example, if I write anyhow, this will become 0. Suppose the statement is according to that, you will get here 0. Then the rank of A is here 2 and the rank of augmented matrix is 3. So in that case the system is inconsistent. But here you are getting 7. 7. So here the rank of A is 3, rank of augmented matrix is also 3. So this is rank of A is equals to rank of augmented matrix is equals to the number of unknowns also. Number of unknowns are here 3 already, x, y and z, and both rank of A, rank of augmented matrix and the number of unknowns are equal. So in this case you will be having rank of A is equal to rank of augmented matrix, then the system is consistent. And if it is equal to the number of unknowns also, then like in this case the number of unknown is 3. So in that case you will be having the unique solution. And if it is, suppose if the rank of A is 2 and rank of augmented matrix is also 2 and the number of unknowns are 3, so in that case you will be getting the infinitely many solutions. So in this way you can solve this. Now after that you can do, now multiply this, you will get 1 minus 1 2 0, 1 minus 1 2 0 3 minus 7. After reducing this matrix into the row echelon form, you will get this. Ax, this system Ax is equals to B will reduce to x, y, z is equals to 2 minus 4 and 7. So when you multiply this, you will get 7z is equals to 7, you will get z is equals to 1. Similarly, you will get 3y minus 7z is equals to minus 4. When you put z is equals to 1, you will get 3y minus 7 is equals to minus 4. You will get 3y is equals to minus 4 plus 7, 3. Again y is equals to 1 and x is equals to 1. So this system of linear equation will have the unique solution as x is equals to 1, y is equals to 1 and z is equals to 1. I hope this is clear to everyone. Next, so this is the example of the non-homogeneous system of linear equations. Next we will study, yes, this is a rank of A, rank of augmented matrix is 3, which is equal to the number of unknowns, so we will be having unique solution. And what is the unique solution here? That is x is equals to 1, y is equals to 1 and z is equals to 1. Next is homogeneous system of linear equations. So homogeneous means Ax is equals to 0. So what is the major difference between the non-homogeneous and homogeneous? See, homogeneous system can be written as this form, right? I have already told that this b1, b2, bn, they all must be 0 in the homogeneous case. So one greater advantage is that one of the most beautiful thing about the homogeneous system of linear equation is that 0 solution is always the solution of homogeneous system of equation. How? If I write any homogeneous system like 2x plus 3y plus z is equals to 0, x minus y plus z is equals to 0, 3x plus 4y minus 5z is equals to 0. You can see this x is equals to, y is equals to, z is equals to 0 is always the solution of this homogeneous system of equation. You can put x equals 0, y is equals z 0, it will always satisfy. So 0 solution is always the solution of homogeneous system of linear equation. So that means the homogeneous system of equation is always consistent. This is always consistent because you will always having the 0 solution. So in this case, inconsistency is never. This will always have the 0 solution. So first thing is the system Ax is equals to 0 is always consistent because 0 solution always exists. Second, in this case, you can see if this will have the unique solution. When unique solution means 0 solution, this will have unique solution. Unique solution means it will have the single solution. That means it will only have the 0 solution if rank of A is equals to n. Rank of A is n. That means determinant of A in this case, if it is a scalar matrix, then determinant of A must be non-zero. And if rank of A is less than n, then it will have infinitely many solutions. We will see with an example that how to solve this homogeneous system of linear equations. That in this you have to remember only two things. If the rank of A is equal to n, then it will have the unique zero solution, and if it is less than n, then it will have the infinitely many solutions. So let's see an example of this. So we have an example. X minus 2y plus 3z is equals to 0. 2x plus y minus 4z is equals to 0. X minus y plus z is equals to 0. So this is clearly a homogeneous system of equation, because all b1, b2, b3, they all are 0 in this case. So this can be written in the form of Ax is equals to 0, where A is the coefficient matrix again and x is an unknown vector. So what will be the value of A here? Write the coefficients of these. 1, minus 2, 3. 1, minus 2, 3. 2, 1, minus 4. 2, 1, minus 4. 1, minus 1, 1. 1, minus 1, 1. So this is our A matrix. Again, you have to check the rank of A. Again, you have to either here there is a 3 cross 3 matrix. You can also check by finding the value of the determinant. But I will go through the general way. I will first convert this matrix into the row echelon form, and we will see what is the rank of A. If it is 3, that means number of unknowns. If it is 3, then we will say that it will have unique solution. And if it is less than 3, we will say that it will have infinitely many solutions, and we will find in that case which infinitely many solutions are there. So here, to convert into the row echelon form, I will convert it into this. R2 changes to R2 minus twice of R1, and R3 changes to R3 minus R2. So this will become 0 and this will become 0, and you will see by applying this you will get the system 1, minus 2, 3, 0, 1, minus 2, 0, 0, 0, x, y, z, and right hand side you will again get 0, because when you apply the operations of 0 matrix, you will again get a 0 matrix. So when you apply these operations on this matrix, you will get this. So now this is the row echelon form. Clearly here the number of non-zero rows are 2. So rank of A is 2 here. You can see that this is last row is the 0 row. So the number of non-zero rows in the row echelon form are 2. That is first row and second row. So rank of A is 2, which is less than 3, because the number of unknowns are here 3. So I have already told you that if this is having unique solution, if rank of A is equal to the number of unknowns, and if it is less than number of unknowns, then it will be having infinitely many solutions. So in this case, the rank of A is 2, which is less than 3. That means we will having the infinitely many solutions in this case. Now we have to find also these infinitely many solutions. How will they look like? So in this case, when you multiply this, you will get this. This is y minus 2y, sorry, y minus 2z is equals to 0, y minus 2z is equals to 0, and x minus 2y plus 3z is equals to 0. So here you will get y is equals to 2z value, and here when you put y is equals to 2z, it will be minus 4z plus 3z is equals to 0, and you will get x is equals to z. So x is equals to z, y is equals to 2z. If I take z is equals to some constant k, then you will get x, y, z, this unknown vector as x is equals to, when you put z is equals to k, then this is k, this is 2k, when you put z is equals to k, y is 2k, and z is equals to k. So in this case, you will be getting 1, 2, 1 into k. That means you can put k any value where k belongs to any real number. So your infinitely many solutions will be the multiple of this vector 1, 2, 1. Whatever, for different values of k, you will be getting different solutions, that is different values of x, y, z. So in this case, we are getting infinitely many solutions, and how will they look like? They are the multiple of this vector 1, 2, 1. So you can see here. So converting this into the Roth-Lund form, here the rank of A is 2, which is less than number of unknowns. So you will be getting the infinitely many solutions, and the solutions will look like the multiple of vector 1, 2, 1, where k is any constant. So I hope this is the homogeneous and non-homogeneous system is clear to you. In nutshell, please remember, if you have non-homogeneous system, then this non-homogeneous system will be consistent if rank of A is equals to rank of augmented matrix. This will be consistent only if this equals to this. And if rank of A is not equals to rank of augmented matrix, then it is inconsistent system. It will have no solution. And if this equals to n, then it will having unique solution. And if it is less than n, then infinitely many solutions. And in case of homogeneous solution, this will be always consistent because zero solution is always there. And if rank of A is n, then only zero solution, that means unique solution. And if rank of A is less than n, then infinitely many solutions. So you can practice such questions from any book like B.S. Grewal and N.P. Bali. And then the last, applications and conclusion. The system of linear equations appears in analyzing forces and structures, optimizing processes, and solving problems in mechanics, thermodynamics, and electromagnetism. So in a nutshell, the matrices provides a great framework for solving and analyzing the system of linear equations. And the key concept includes the relationship between the rank and the solution of the matrices. I hope you enjoyed this lecture. Thank you very much.